Hi, this is Miss Litton, and this is 7th period support, chapter 45, community and ecosystem ecology. Say hi.
Hi.
That was weak.
Hi.
Hello. So the reason why they're so tired is because they just learned this all today. But we need to do the review today anyway. So first of all, when we look at communities, right, when we look at species diversity, we want to look at what are all the species we have and how much of them do we have. We talked about islands. Let's see if we can remember what we learned about islands. How can I have the greatest biodiversity on an island? Near or far from the mainland?
Near.
Near. So close to the mainland. And big or small island?
Big.
Yep. We saw that based on data. So when we run through this, when we look at these two graphs about speciation, and number of rate of extinction and whether you're a large or small island, when we look where everything crosses right here, we want to have a large island that is close to the mainland, and that gives us the greatest species richness or biodiversity. Okay, we'll put a pin in that, we'll remember that and apply it for a few chapters. Next, we talked, sorry, all on, I'm going to give a new page here, species interaction. Okay, what do you call the word where you live?
Habitat.
Habitat. Okay, so if I have this area that is my habitat, what do you call what habitat? What do you call what you do?
Ecological niche.
Niche, okay? So let's break it into some different categories. What are some niches that you could have? You could be a autotroph, you could be a producer, or you could be a consumer, or you could be a what? Decomposers. Do you see how they're all living in the same habitat, but they all have a different job? Yes? Okay? Now, let's say you have two consumers, consumer A and consumer B, and they want the same thing. What will they have between each other?
Competition.
Competition will be between them. Are we all right with that? Now, let's say species A and B, okay, they're both good living in all of these areas, but species A lives in this area and species B lives in this area. What are we doing right now? What is that called? Resource partitioning. And I'm doing that because what's my other option?
To kill one.
To kill the dog, right? So that was sorry. So that is one species lives and the other one dies. When you do resource partitioning, it can be in space or in what? Time. Time or space. And that is in order to decrease the amount of what you have? Competition. We okay so far? All right, so that's several slides. Several slides. Okay, close your eyes, don't look, because there's going to be an answer here, and you can do all the questions as we go along. I think there might be. Move all students. Don't look, don't look. Oh, log in, sorry. I started it without you logging. Log in as what you're looking forward to over spring break. Did you say rice?
I remember. Oh, I'm already in.
Yeah, because I started it. So as soon as you log in, go.
No, I didn't even log in. I just went to Help Us Smart and it put me in.
Oh.
Well, this is log in as I don't answer the question. It's C. It's C. A. It's also A. It's also A. It is A. Wait. It's not. Howard. It's not. No, it's not. I don't know what Howard is saying. Oh wait, no, it's not the point. Yeah.
Are you ready?
Oh, we just did this one.
Yeah, we did just do this one. Is an ecological niche the same as habitat? No. can a niche be occupied by another species? No. Who says no? The competitive exclusion principle says no two species can occupy the same niche. Okay. Hats and hoodies are off. So we only had one person struggle on this one. They don't want to waste time fighting, right? That's why you do resource partitioning. Unless you think you can win and kill that species off, for sure, okay? But that's why you will do resource partitioning. So then we started talking about predator-prey interactions, okay? Now, on predator and prey, what do you typically see on those predator-prey interactions? Cycling, right? As the prey numbers go up, what else goes up? Predators, right? As the prey numbers go down, what goes down? Predators. And it could be just due to their interactions or something in the environment, something like how much food is available for the prey. But then we started talking about defensive mechanisms, how to be, and we talked about coevolution, pushing each species, pushing each other to change to be a better predator or a worse prey, right? So what were some of the ways, what were some of the predator defenses or prey defenses? Mimicry. Okay, so let's talk about that. Mimicry. Okay, Batesian and Mullerian. Okay, what was an example of Batesian mimicry?
You make yourself look like something that has defenses.
Okay, so you make yourself look like something that has anti-predator defenses, right? You make yourself look like something that has a stinger or a bite. So you're trying to get them to take the bait, okay? But bees and wasps and hornets are all black and yellow. What kind of mimicry is that? Mullerian. Stinger, right? What's another thing you can do besides mimicry?
Like have spines on yourself.
Spines on yourself? Are you talking about a plant?
Yeah.
Okay. So plants can have stinging cells. They can have spines. They can be in a relationship with another organism. What's an example like that where a plant defends itself and it's in a relationship?
The
caterpillar and the wasp, except that's not a plant.
The plant calls for the...
Oh, okay, got you. I got you that. Good. What's another one that we looked at today? Yes?
The ant and the hollow thorns.
Yeah, ant and the acacia tree. They both start with A, if that helps you. Ant and acacia tree. So the acacia tree provides a home, hollow thorns, and food, and the ant defends it against other herbivores. Exactly. So that was a mutualistic relationship in order to defend themselves. What else? Besides mimicking an organism, you can mimic your environment, right? Mimic your environment so you blend in with the environment. Or what's another way you can defend yourself?
The puffer fish.
Yes, what am I trying to do right here? Fright. Yeah, fright. You can also be poisonous. What do I do to advertise that? Bright colors. There you go. All of those are predator-prey defense mechanisms, and that was another whole section, and we're good on that. Boom, 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 boom. Now, we talked about community interactions. Then we said communities changing over time, or who inhabits what community. So we did a quick review of plate tectonics, because we wanted to remember that species are going to colonize those areas, right, that they have access to and that have the right climate and conditions. What else can influence? Where did we see really high biodiversity? Near the equator is another one. And what's a big factor that people don't think about, but it has a big factor in what gets to what area? What is that? Chance. What was I doing right there? Yeah, chance has a big factor in who gets to which area. And then they just have to compete. Yeah, they have to outcompete one another in order to survive and reproduce in that area, right? And then we said, okay, well, what if that area is just like clear cut, right? What if we just, if there's been some sort of disturbance within it? We talked about two different starting points. What were our two different starting points? Primary succession and secondary succession. What would be an example if I'm at primary succession? A rock. Okay. And is that going to be faster or slower than secondary?
Slower.
Why?
Because it takes a lot longer for
To make what? Soil. And why do I need soil?
So
Grow plants. They're at the bottom of the food chain. They are the producers, right? Secondary succession, what do you have?
Soil.
Okay, and so it goes, it's more rapid. What's an example of secondary succession?
like a fire.
Yep, a fire going through, yes. We talked about that, And then we gave an example in Yosemite, or sorry, not Yosemite, Yellowstone. In Yellowstone, do you remember what we looked at? To have the greatest biodiversity, we needed to have what? Not just fires, it was intermediate disturbance, yes. Okay, so you want, and with an intermediate frequency, not too much, not too little, right? Not too often, you don't want to have it rarely. It needs to be intermediate, and that seems to provide the best health for biodiversity. Possibly because anything that's caught up in dead plant or plant materials gets recycled and decomposed really rapidly right through the fire. Some sort of disturbance like that. Okay, and here we go. Did I skip any other one before that? I don't think so. We did that one, right? Did we? Did we do this one? No, we did not. Okay, close your eyes. Because last class's results are up there. I should have reopened the whole thing.
Hey.
We have weird people in here, so come back in. There we go, we're ready. Freedom. Naomi's getting married? Are you kidding me? Sorry. And again. Yay!
What? I knew this. Wait, it's the same thing. It's the same one.
Hey, don't look.
Guys, don't look.
Don't look.
Oh my god, let's see the answer. It's D.
Howard, before you put out the exam,
You need attention.
you got bad food though.
Sorry, I forgot to pause it. Just hang in there.
Oh, it's up there.
Yeah, pretty soon fifth period stopped.
After this one, it stops.
It's like done. Yay! Yay! Okay. Now, next part. This is easy peasy, lemon squeezy. So everything starts with what? Sun. Good. And then we have what?
Plan.
Names. Autotroph? Good. What else? Producers? First trophic level. Anything else? Now, what kind of autotroph is this? Yeah, a phototroph. What I drew was a phototroph. What's another one that's an autotroph? Chemotroph, but I might see that in an area like where there is detritus, right? Something like that. Yes? Okay, who does this go to? A what? A heterotroph? Okay, so here I'll try again.
What is terrifying?
Is that a
Bunny.
Wait, that's a wait.
What is he?
Wait, that's not a bunny.
A heterotroph? What else? Second trophic, he's at the second trophic level. What else? Primary consumer. What else is he? Herbivore. Okay.
Draw a tiger now.
That's
Oh,
one
that was a
button.
great tiger.
Tiger.
It was a dinosaur.
Oh, she's doing that one. Oh, is that the
What
tiger?
happened to the bunny?
Yeah. The tiger.
Well, she didn't draw the tiger for us.
You didn't draw that.
Ours was a
That's
dinosaur.
a T-Rex.
That's a T-Rex.
Don't touch the drawing.
Okay. What is he?
A lot of things.
He's a card.
He's a carnivore.
He's in the third show.
Third trophic. What else? He's a heterotroph. What else?
Secondary.
Secondary consumer. Did we hit them all? We got carnivore.
Yo, what is that? Is this what were you trying to draw?
I'm sorry you guys aren't educated to know what you're doing.
Whoa.
All right. How much gets passed on each time?
10%.
Yeah, probably about 10%. Oh, I'm still writing in. Okay. So we could not read that. But we could stack these up into ecological pyramids, right? And we could talk about the pyramid numbers. There's more blades of grass or flowers than there are bunnies, right? But that doesn't always work. So then you could do pyramid of biomass. We could weigh all the flowers, weigh the bunnies. That one weighs the most, whatever that one is. But the best one is the pyramid of energy. Good. All right. So who works on breaking all of this down? Decomposers, and returns it, doesn't disappear it, but returns it to the soil. Perfect. Okay, so that was that whole section. Come here.
This is. Yeah, we haven't done this one yet.
No more.
There's one on 90.
Did I skip one?
Yeah.
Okay, I'll go back to it. Okay, thank you. Oh. Now, you don't even need the picture to answer the question. Right? Do you need the picture to answer the question? No. You could just go, oh, a caterpillar, that's a consumer. A frog is a consumer, an owl is a consumer, and a snake is a consumer, right? Because they're not autotrophs, right? So the only thing there would be the flower. And I'm a highlighter. Okay, and then which organism is at the third trophic level? Most of you got that, plus it was labeled, even a few of you said it out loud. But the flower was 1. Then who came next? Caterpillar was 2. And then the frog was eating the caterpillar, so he was 3. Then the snake would be 4. And the owl would be 5.
Just to let you know, we didn't see the caterpillar.
How can you see the caterpillar?
We clicked it, we just didn't notice it was there.
It was camouflage.
And I skip.
I just saw like a weird thing, but you can see that it says.
Yeah, what do you
But it,
on a quiz, you wouldn't just like.
no,
I take longer on a quiz.
you didn't mention it.
Herbivores. Producers are herbivores, trust me. Wait. Yeah, it's a
Foxy and Songless.
Hey, Howard, we don't say things out loud.
Wait, why is the option for all of
Wait,
them
it's
correct?
not all, because it's primary. It's up here too.
I remember like reading
Yeah, is there,
You got it wrong.
All right, good. Producers are autotrophs.
yeah, so right.
Almost. We have one person who struggled on this. When they said bee, lady beetle, it's like a ladybug, eating aphids. Why wouldn't that be a primary consumer in a vegetable garden? Aphids are the primary consumer. The lady beetle is a secondary. Good. All right. Then that just brings us to our biogeochemical cycles. And for that, we want to make sure we remember reservoir, exchange pool, and community. And I have a bunch of questions on this one for you. So we'll probably start with the questions, just review a few of them. Remember, the reservoir is normally not accessible by the autotrophs. Remember, the autotrophs are the beginning, right? They're getting the energy from the sun, yes? Okay. And then the exchange pool is where the plants get access to it. And then the community is just as it moves from producer to consumers and through the consumer community, and then decomposers break it down again. So we talked about the water cycle, and we talked about that only 3% of it is fresh water. But we looked at some of the words in there. We're okay with that, right? Okay. And then we talked about how man can screw it up. Okay. Then we talked about the carbon cycle. And in the carbon cycle, the concern we would have is having too much carbon in the air, right? Carbon dioxide and other gases, which would trap heat and increase the global mean temperature, and we call that global warming, and then there are results from that as well. So we look to see, well, what are things that reduce the amount of carbon in the atmosphere, and the only thing that does that is photosynthesis. The cellular respiration removes oxygen and increases CO2. So does combustion. To burn a fire, for an engine to burn, it needs oxygen. So it consumes oxygen and produces CO2. And then decomposition, remember, any consumer is going to do respiration. And then, well, most consumers. And then decomposers are heterotrophs, so they're also doing cellular respiration. And let's talk about this for a minute, because I think we went through this pretty fast in class. Gross primary productivity. Let me tell you where you might see this more likely, would be in a lake. Okay, so you have plants, like, and let's say the top level of that lake. And you have light that can penetrate down. Now, in that body of water, okay, in that lake that you have, okay, this top level right here is going to get the most light. So they're doing their photosynthesis, and they're producing a lot of sugars, right? And they're having to do respiration, but they probably have a higher net primary productivity at the top of that lake. When you go a little deeper, there's less light, so their gross primary productivity is going to be less, but they're still doing respiration, so their net is not going to be as much. The deeper you go in the body of water, the less productive it becomes, because there's nothing left over for who? The consumers, right? Because what we have left over would be available for the consumers. So when you look at these different areas like estuaries, tropical rainforests, you're looking here at their net primary productivity. And we talked about that. We have the greatest biodiversity near the equator, right? Well, because we can support, guys, you don't need to be here. We can support the most plants, right, at the equator, because you have the most light energy, most direct light energy, so you can do the most photosynthesis. As you move farther away from the equator, you have less light, right, available to just you, less energy, so that your productivity goes down. And that's why we can see that. In the open ocean, you have issues with nutrients, depth that you can do photosynthesis, and organisms that are phototrophs that are out there, right? Okay, so I wanted to make sure I reviewed that with you. And then phosphorus cycle. The reservoir for phosphorus is in the rocks, and the easiest way for it to get out is due to weathering. And most organisms are going to get their phosphorus from plants, and plants are going to get it from the soil. If the soil doesn't have it, that's why it would need to be added to the soil, and that's what we use when we use fertilizers. Fertilizers always give your NPK percentages. What are the three elements right there? Nitrogen, phosphorus, potassium. Yeah, they're putting that into the soil because that gets depleted out of the soil. But if you put in too much, like excess fertilizer runoff from a dairy farm or whatever, then you can get these algal blooms. And the concern with algal bloom is normally you have phosphorus as a limiting factor, but if you have it now, then you have all this algae, and as a result of all that algae living there, and that algae dies, who's going to work on that algae? Decomposers. Decomposers require what gas? Oxygen. Who else requires the gas? The fish. And so what happens is the fish die. Okay? So that one is under your notes on eutrophication of a lake. And so it gets hit in one other unit, even in the next unit, but you want to address it a little bit here. And these types of things contribute to that. And then last but not least, the nitrogen cycle. Okay? In the simplest form, you can see in this like childlike 7th grade diagram, nitrogen in the air. To get it into the soil, you have to use what kind of thing? Bacteria. And you do nitrogen fixing bacteria. Then nitrifying bacteria convert it to nitrite and nitrate. Then it can get into plants, and then animals can eat it, and plants and fly around, decomposers, and it gets it back into ammonia. Let me jump up a picture, a little more detailed. Okay? So here you have nitrogen fixing bacteria that are converting it from the air, okay, into things like ammonia. Then nitrifying bacteria are going to convert this ammonia first into nitrites, NO2-, and then nitrates, NO3-. This can be used by plants, and then animals can eat these plants, and both plants and animals can be broken down by decomposers, and you're back to ammonium again. And this is just staying in the community right here. If you want to return nitrates back in, then we use denitrifying bacteria, which return it to the atmosphere. Another way you can do nitrogen fixation is atmospheric fixation using lightning, and also industrial fixation will do it as well. This I think I got from an oil and gas website, but it also, if you just kind of look at this, you should have no problem when you see here's a reservoir for nitrogen, there's atmospheric fixation all the way here to the outside. Then here's some fertilizers. Here's nitrogen fixing bacteria, and you're getting it into ammonium. At ammonium, you need to use nitrifying bacteria to get it to nitrite, and then nitrates can be used by plants, and then those can go to animals. And denitrifying bacteria return it. And then we talked about at the very end, the last thing on the notes that you took was just about pollutants that can add harmful chemicals into the atmosphere, can come down in acid rain and cause problems. So before we do, I have a bunch of review questions. Before we do those, let's do the nitrogen cycle one more time so you have it in your head. Here we go. Nitrogen fixing bacteria are going to convert N2 into ammonia. Okay? It's not helpful to plants. So then we have nitrifying bacteria. First nitrite, then nitrate, NO3-. We can serve this up to plants, and then animals can eat the plants. The plants and the animals can die. Who works on them? And we're back to ammonia. Nitrifying bacteria, nitrite, nitrate. What's another way I can get nitrate? Atmospheric fixation or industrial. If I want to get this nitrogen back into the atmosphere, I need, again, help from denitrifying bacteria. Nitrogen fixing bacteria, just like carbon fixation in plants, photosynthesis, dark reaction, Calvin cycle, light independent reaction, yes? RUBP, that's carbon fixation, taking CO2 out of the air. This is N2 out of the air and fixing it into ammonium and then converting it to nitrite and nitrate. Are you ready?
Yes.
Okay. 9 questions. I'm going to pause it here.
What?
What?
I need.
Okay, let's see what happens.
Okay, let's go.
Oh, great.
Oh, actually, I
Not the first one.
What?
Ah. Oh, here, let's show questions.
What? Can we do them again?
Okay.
Yeah, we remember all our answers. So
Okay. Sorry, just a moment here. Okay, guys, can we please just go through them quickly together instead of having you all be at different spots? Okay, that way it'll facilitate any kind of discussion. So here anybody else? Okay, go. Good job. Number 2. Yeah, the water cycle is not a sedimentary cycle. Most abundant gas, nitrogen. Most of you got that. Nitrate to nitrogen gas. Good job. Uh-oh. Nitrogen gas to nitrate is nitrogen fixation. How could you have done that? What's it called? Atmospheric fixation. Using lightning will go right from nitrogen gas to nitrate. Right? That's a form. Because, let's see if you said nitrification. Nitrification is taking ammonia, NH3, and forming nitrite or nitrate. That is nitrification. Do you see the difference there? Okay. And then nitrogen gas to ammonium is nitrogen fixation. Good job. Nitrite to nitrate. Good job. Almost good job.
We weren't sure about A.
Which one?
A and B.
Most carbon dioxide in the air and water mixes with water to form bicarbonate. Yep. And then what was the other one? B? Or what one? B. Eutrophication is over enrichment. Yeah. That's what we saw there. And that's it. The end. 2 chapters left. Good job.
Our next quiz should be a partner quiz.
No. I hope you have a good evening. I hope you're not waiting till the last minute. And if you're hungry, yes, have a piece of toast.